Now, the exercise of clocks, exercise 12. Let's take the first question, question number 1. It says, at what time between 3 and 4 o'clock are the hands of a clock together? Now, when the hands of the clock are together, the angle between them is 0. And for the angle between the hands, we have a formula that angle theta is equal to 30 into the integer hour value, the r value which is the previous one. So here it will be 3, right? So 30 into h minus 11 by 2 into m, that is the minute value. So h is the smaller r value and the minute is the minute value, right? So the moment is hm. So at any moment hm, h hour and m minutes, this is the formula for angle, right? Here the theta angle is 0, h value is 3 because anything between 3 and 4 would be 3 something. So h is 3, so 30 into 3 minus 11 by 2 into m, right? So 11 by 2m is equal to 90. So m is equal to 90 into 2, 180 by 11. If we simplify, it will be 11 one time, then 70, 66, so 6 times, and 4 by 11 minutes. So the time would be, the moment would be 3:16 4 by 11. This is the time at which the minute hand and hour hand would be together between 3 and 4. So if you look at the options, it is 16 4 by 11 minutes past 3. That is B option. Alright. Now there is one more way of doing this question. Let's say the other method for this question. Now that other method is based on the motion or the time speed method, we can call it. Okay, let's see how we do it. Draw the situation at 3 o'clock. So at 3 o'clock, the situation would be something like this. The minute hand would be at 12. This is the minute hand. And the hour hand would be at 3. This is the hour hand, right? Now, what is the angle between them? Angle between them is 90 degree. Alright, so the distance between them, so we take the angle as the distance. Now, what is the speed of minute hand? The speed of minute hand is in this direction, and the speed of minute hand is 6 degree per minute. Now, how do we know that? We can check that also. The minute hand takes 1 hour to take full round. Now, in full round, the minute hand can cover 360 degree. Divide by 60 minutes. So from there, we get the speed of minute hand as 6 degree per minute. Now, our hand is going in the same direction, right? And the speed of our hand will be, how will you calculate speed of our hand? Let's see. Speed of our hand is half degree per minute. Half degree per minute. How do we get that? Let's see. The our hand takes 12 hours to complete one round, right? So 12 hours would mean the total angle would be 360 degree, and divide by 12 into 60 minutes, right? So it will be 360 by 720 and hence half degree per minute. Alright, so this is how we calculate the speeds. Now we know that there are two things chasing each other. You know, the faster one is behind, the distance between them is 90 degree. The minute hand is the faster one and it is behind. The speed is 6 degree per minute, right? Our hand is moving forward and speed is half degree per minute, right? It's the same situation of same direction. So the time taken to meet would be the distance divided by the relative speed, that is 6 minus half degree per minute. Alright, 6 minus half degree per minute. Right, so the answer will be in minutes and it will be 90 divided by 11 by 2 minutes, which is 180 by 11 minutes, and that is equal to 16 4 by 11 minutes. So this is the other way of doing it. So the time would be 3:16 4 by 11. Hence the option B is the correct answer. Alright. So from here in this question, you should memorize that minute hand speed is 6 degree per minute and hour hand speed is half degree per minute. Now let's take up the next question. It says, at what time between 7 and 8 will the hands of a clock be at right angle? So if we apply the first method where the angle theta is equal to 30 into h minus 11 by 2 into m, and put the theta value equal to 90 degree. Why 90 degree? Because we want the hands to be at right angle. So when they are at right angle, the angle between them would be 90 degree, right? Now h is the smaller hour, that is between 7 and 8. Anything between 7 and 8 would be 7 something. So h is equal to 30. So 30 into 7 minus 11 by 2 into m. So we get 11 by 2 into m on the other side, and 30 into 7 is 210 minus 90. 210 degree minus 90 degrees is 30 degree. Okay, so it comes out to be 120 degree. So m is equal to 120 into 2 is 240 degree by 11. Now if you divide, you will get in minutes. This will be in minutes. So 240 by 11 would be 240 by 11. So 11 twos are 22. Then 1 9 by 11 minutes. So this is the required value of time. That means the moment would be 7 21 9 by 11 minutes, right? So if you look at the options, it is 21 9 by 11 minutes past 7. That is option B. If you apply the other method, that is the distance method, let's see. So the other method for question number 2, it would be done like this. First, draw the situation at 7 o'clock. So 7 o'clock, what will be the situation? Let's see. At 7 o'clock, the minute hand is here at 12, and our hand is at 7. Our hand should be at 7, right? This is the R hand. Now the total distance between them in terms of angles in this direction, in clockwise direction, is 210 degree, right? But we want a situation where the angle becomes 90 degree. So somewhere here. So if this angle is 90 degree, then the angle required by minute hand to travel is this one. And that angle required to be traveled is 210 degree minus 90 degree, that is 120 degree, right? So the distance to be covered is only 120 degree to make the angle between them equal to 90 degree. All right, we already know the speeds of minute hand and hour hand. Speed of minute hand is 6 degree per minute, and speed of hour hand in this direction would be half degree per minute. All right, so the time taken would be the distance 120 degree divided by 6 minus half relative speed, because they are in the same direction, per minute. So it is 120 divided by 11 by 2, which is 240 by 11, which is 21 9 by 11 minutes. And the moment would be, it is after 7 o'clock, so the moment would be 7 21 9 by 11, and hence the option B. So these are the two ways that you can apply in most of the questions. Alright, now let's take up the third question. Find at what time between 8 and 9 o'clock will the hands of a clock be in the same straight line but not together. That means they're opposite. So if they're opposite, the angle between them would be 180 degrees. So we still apply the same formula, theta equal to 30h minus 11 by 2m, and we put 180 degree in place of theta. And we take h value as 8, the smaller one. So 30 into 8 minus 11 by 2m. So 11 by 2m on this side, and the other side would be 30 into 8 is 240 minus 180, which is equal to 60. So m is equal to 60 into 2, 120 upon 11, and that comes out to be 10 by 11 minutes, right? So, and we have the moment is between 8 and 9, minutes is 10 by 11. So the required time is 8 10 by 11. This is the moment. That is 10 by 11 minutes past 8. That is option C. So obviously this method is a little faster. For the other method, you again start from 8 o'clock. Other method of question 3, you draw the situation of 8 o'clock first. So what is the situation at 8 o'clock? Let's see. At 8 o'clock, the minute hand is here at 12. This is minute hand, and is going in this direction at a speed 6 degree per minute. And the hour hand is at 8. Alright, so I am showing 6, 7 and 8 all. This is the original situation of R hand at 8 o'clock. Now the angle, total angle between them is 240 degree. That you can check. 30 into 8 in this clockwise direction is 240 degree. Now if I want the hands to be opposite to each other, that means minute hand should travel this much distance. Now how much will be this much distance? Let's see. When they are opposite to each other, the net angle between them should be 180 degree. The original angle is 240 degree. So the distance required to be traveled is 240 degree minus 180 degree. That is equal to 60 degree. So the distance required to be traveled is 60 degree. The minute hand is traveling at the speed 6 degree per minute. R hand is traveling in this direction at the speed half degree per minute. Alright, half degree per minute. Okay, so the time required would be distance 60 divided by relative speed, same direction, 6 minus half. Alright, so it is equal to 60 divided by 11 by 2. Hence it is 2 goes into the numerator. 60 into 2 is 120 divided by 11. Now 120 divided by 11 is 10, 10 by 11 minutes. So the moment would be, and this is after 8 o'clock, so the time would be 8, 10, 10 by 11. Alright. Right? So the answer option should be the C. Okay. Now the fourth question is the direct application of the formula that we have learned. It says find the angle between the two hands of a clock at 30 minutes past 4 o'clock. That is 4:30. Alright. So H is equal to 4 and M is equal to 30. So the theta angle is straight away equal to 30H minus 11 by 2M. So it is 30 into 4 minus 11 by 2 into 30. 2 cancels 30 15 times. 30 fours is 120 minus 11 15 times is 165. So the answer is minus 45 degree. Now what does it mean? We say that the angle is 45 degree. The minus sign means that the minute hand has crossed our hand from 4 o'clock to 4:30, which is obvious. You see, at 4 o'clock, the situation was at 4 o'clock, the situation was minute here, minute hand here, and our hand at 4, right? This is our hand. But at 4:30, what is happening at 4:30? Check it. At 4:30, minute hand is at 6, all right? And the R hand is between 4 and 5, right? It's here. R hand is here. This means from here to here, the minute hand has crossed our hand. So whenever this situation will happen, angle will always come out to be negative. So don't worry about it. The angle is always the value of that angle that you get. All right. Now, let's take up the next question, that is question number 5. Let's read the question first. It says, how often between 11 o'clock and 12 o'clock are the hands of the clock an integral number of minutes apart? There are multiple ways to interpret this statement. Okay, let's take one by one. All right. Now, first, I'll tell you that the answer given in the answer key at the end of the book is not correct. All right. So first, listen very, very carefully. There are total 3 ways of understanding this question. All right. So first, we'll take exactly what is given in the question, the words exactly given in the question, and it says integral number of minutes apart. Right. So that means the difference between them should be integer in minutes. What exactly is the meaning of this? First, let's to try to understand that. Let's draw a situation of a clock. All right. This is the center. Let's say this is the position of 12. This is the position of 1. This is the position of 2. This is the position of 3, right? Now, from 12 to 1, or you can say that this entire one round is equivalent to 60 minutes for minute hand. All right. So what we can say is that the entire clock can be divided into 60 spaces, and each space is called 1 minute space. All right. So from 12 to 1, the whole thing can be divided in 5 equal parts. And each part, you can see I am putting the star mark here. Each part is a minute space. All right. Now in this question it says between 11 and 12. Now at at 11 o'clock, what exactly is the situation? At 11 o'clock, the hour hand will be at 11 and the minute hand will be at 12. So from 11 to 12 also, there are 5 gaps or 5 spaces. So there are 5 minute spaces. So at 11 o'clock, you see that the how many minute spaces are the minute hand and hour hands apart. So H is the hour hand, M is the minute hand. So at 11 o'clock they are apart. The hands are 5 minutes apart. This is what we can say. All right, 5 minutes apart. Now look at this very, very carefully. So at 11 o'clock, they are 5 minutes apart, right? Now, from 11 to 12, what all will happen? This minute hand will move or will take one complete round, and this hour hand will just go from here to here. All right? Minute hand will take one full round, and hour hand will go just from 11 to 12. Okay? Now, during this period, what all is going to happen? We know that the entire one complete round for minute hand is going to be equivalent to 60 minutes. All right. When they are together at 12 o'clock, I can say that the hands are 0 minutes apart. All right. Please note these things very, very carefully. At 11 o'clock, they are 5 minutes apart. At 12 o'clock, they are 0 minutes apart, right? Now, what happens between 11 and 12? That is what the question is asking. What is going to happen between 11 and 12? Now, initially at 11 o'clock, the distance between them was 5 minutes. What happens? The moment we move, ahead of 11 o'clock, after 11 o'clock, the minute hand will move like this, hour hand will move like this. But the minute hand is faster, hour hand is slower. So after some time, so initially at 11 o'clock, the gap was 5 minutes, or they were 5 minutes apart, right? After some time, because the minute hand will be faster and hour hand will be slower, the gap will increase. This gap is going to increase. This is the minute space. All right. So it will become 6 minutes. Then it will further keep on increasing. In one situation, when the minute hand and hour hand will come exactly opposite to each other, that this will be some situation like this, which will be around 11:25 or 11:26. At that time, they will be exactly opposite each other, or the angle between them will be 180 degree. At that moment, the minute gap between them will be 30 minutes. How do we say that? Listen very carefully. The total entire round is equivalent to 60 minutes. Here, when the minute hand and hour hand become opposite to each other, the gap will be of 30 minutes, right? So at 11 o'clock, the gap was of 5 minutes. After some time, it will be 6 minutes, then 7 minutes, then 8 minutes, up to 30 minutes. All right. So at some point in time, we don't need the time. I'm just saying that at some point, the gap will be of 30 minutes. Now, what will happen after that? After that, the minute hand will start closing in, will start getting closer to our hand, right? In that case, the minute gap or the gap in terms of minutes will keep on reducing. So it will become 29 minutes. And in the end, at 12 o'clock, we have already seen that the gap is going to be 0 minute. So it will go up to 0 minutes. All right. Now look at this very, very carefully. So at 11 o'clock, it was 5 minute gap. At 12 o'clock, it is 0 minute gap. And during this period, what has happened? The gap has gone from 5 minutes to 30 and then to 0. So if I am only counting the gaps which are integral in terms of minutes, it will be from all the integer values from 6 minute to 30 minute. Then from 29 minute, and in the reverse order, 29 minute in the reverse order to 1 minute, right? We don't have to count at 11. We don't have to count at 12, right? Because the question is asking between 11 and 12. All right. So this will be from 6 to 30. It is going to be 25 occasions. And from 29 to 1 in the reverse order, it is going to be 29 occasions. So total number of moments or total number of occasions will be 25 plus 29, which is 54. So please understand that answer of given question is 54 times. All right. Answer of given question is 54 times. Okay. So the answer given at the back, which is given as 5, is wrong for this question. Right. I'll tell you when the answer will be 5. As of now, what I have explained is the given question. For the given question, it is 25 plus 29, that is total 54 times it is going to happen between 11 and 12 o'clock, that the hands of the clock are at a gap of or at an integral number of minutes apart. All right, be very careful. So for the given question, 54 is the answer. Now we'll look at another way of interpreting the same question. All right. Now I'll explain the different way of looking at this question, though actually that is not right for the given words of the question. Okay, there is entirely a different question, right? Let's look at the different question for which the answer given at the back is 5. Okay, it says how often between 11 o'clock and 12 o'clock are the hands of the clock simultaneously at an integral number of minute or at an integral value of minute. There is no apart in that question, right? I'll write the question: how often between 11 and 12 the hands of the clock are simultaneously at an integral value of minute, right? This is an entirely different question, right? And by mistake, the answer is given for this question. Let's understand the process of this question. So at 11 o'clock, this is a much easier question because at 11, the minute hand is at 12 and the hour hand is at 11. All right. The gap between them in terms of minutes is 5. So there are 5 gaps from 11 to 12, right? Now from 11 to 12, what happens? At 12, the minute hand is again at 12. At 12 o'clock, the minute hand is again at 12 and the hour hand is also at 12 only. All right. Both minute and hour hand are at 12 o'clock. But what has happened from this situation to this situation? You see, the minute hand has traveled the entire round, which is equivalent to 60 minutes, and the hour hand has traveled only this much distance, which is equivalent to 5 minutes. So the time in which, so I can say in the same time, our hand has traveled 5 minutes. 5 minutes of distance, or 5 minutes equivalent of distance on the clock, and minute hand has traveled 60 minutes of equivalent distance. Now this means for every 1 minute of our hand, minute hand will travel 12 minutes, right? For every 1 minute of our hand, minute hand will travel 12 minutes. All right. So that means now our hand, it was already at a position of 55 minutes and it has go up to a position of 60 minutes. The hour hand is already at a position of 55 minutes. You know, if I divide the entire circle of clock in 60 minutes, 60 parts, so each part will represent 1 minute. So already the hour hand is at a position of 55 minutes. It has to go from 55 to 60. That means the positions of our hand will be 56, 57, 58, 59. In fact, okay, so these are the only 4 situations, because when it becomes 60, it will be at 12, and the question is asking only between 12. So do not include the moments of 11 o'clock and 12 o'clock. So it is 56, 57, 58, and 59. At the same time, position of minute hand is going to be at, we have already seen For 5 minutes of hour hand, it is 60 minutes of minute hand. That means for 1 minute of hour hand, it will be 12 minutes of minute hand. So it will be 12, 24, 48 and 12, 24, 36 and 48, because the next 60 it will be at 12 o'clock. So don't include the moment at 12 o'clock. So there are, the moments would be 11, 12. The time shown in the clock will be 11, 12. That is the first moment. Then 11, 24. 11, 24. Then 11, 36. And then 11:48. These are the only 4 occasions. So answer to the given question will be 4 times, right? You have to note this very, very carefully. Answer to the given question is only 4 times, okay? So even if we interpret in a different manner, still 5 is not the correct answer. The correct answer is only 4 times. All right. So here the question is entirely different. We are not talking about apart, being apart. We are talking about both of them simultaneously at an integral value of minute, right? Both of them simultaneously at an integral value of minute, right? So our hand has limited options. It was already at 55. It can go up to 56, go up to 57, go up to 58 and 59. Correspondingly, the minute hand will go at 12, 24, 36 and 48. So these are the only 4 possibilities that they had for both of them to be simultaneously at an integral value of minutes. So even if the interpretation is changed, the answer is still 4 times. All right. Now question number 6, it says the number of times the hands of a clock are in a straight line every day, right? So first let's look at a cycle of 12 hours. Now within a cycle of 12 hours, the minute hand and hour hand of a clock are in a straight line within an hour 2 times. How? It's because within every hour they're going to meet once and they're going to be exactly opposite to each other. So it is in general, I'm not saying exactly, it is in general, once together and once opposite, and in both the cases we can say that they are in the straight line. So it in general it is 2 times every hour. All right, 2 times every hour. Okay, but now let's talk. Now let's look at some exceptions. Say for example, if we talk about together. So are they together between 12 and 1? Yes, 1 time. Are they together between 1 and 2? Yes, 1 time. Are they together between 2 and 3? Yes, 1 time. 3 and 4? 1 time. 4 and 5? 1 time. 5 and 6? No, 0 time. Between 6 and 7? No, 0 time. But together, what these two situations together, there is once that they are no, between 5 and 6 they are together. Yes, they are together. I'm so sorry. 1 second. We are talking about together. So between 5 and 6 once, between 6 and 7 once, between 7 and 8 once, between 8 and 9 once, between 9 and 10, between 9 and 10 once, between 10 and 11 once, and between 11 and 12, that we have already counted here, right? That we have already counted here. So total how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Please notice that between 11 and 12, the meeting happens at 12 o'clock. So that goes in the next hour. So don't count it here, right? So here between 12 and 11, we have already counted this one. This was happening at 12 o'clock. Others were happening between the hours. So total 11 times together, right, in 12 hours. Okay. Similarly, if you talk about opposite, are they opposite? Or how many times they are opposite between 12 and 1? Are they opposite? Yes, once around 12, let's say around 12:30, 12:35. Are they opposite of each other between 1 and 2? Yes, once. Between 2 and 3? Yes, once. Between 3 and 4? Yes, once. Between 4 and 5, yes, once. Between 5 and 6, no. Between 6 and 7, no. Right? And for both of these together, there is once at 6 o'clock. It is happening once that they are opposite to each other. Alright. Now between 7 and 8, once. Between 8 and 9, once. Between 9 and 10, once. Between 10 and 11, once. And between 11 and 12, again once. So total how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in a cycle of 12 hours, the hands are opposite to each other total 11 times, in total 11 times opposite, right, in 12 hours. All right. So if you see, in a cycle of 12 hours, in 12 hours, they are either opposite or together total in straight line is equal to 11 plus 11, that is 22 times. But the question is asking about in a day. All right. Now in a day there will be two cycles of 12 hours. So in a day the same question or the answer would be equal to 22 into 2, because in a day there will be two cycles of 12 hours. So 22 into 2 would be 44 times. So answer of this question would be 44. All right. Now next question, question number 7. It says, at what time between 4:30 and 5? All right. At what time between 4:30 and 5 will the hands of a clock be in a straight line? Alright. So whether it is 4:30 and 5 or 4 and 5 is the same situation. Alright. So we'll just take it 4 and 5. 4:30 doesn't matter, right? Because in any case they would have met between 4 and 5 only once, and similarly in any case they would be uh, uh, in opposite to each other only once, right? Okay. So between 4 and 5, let's say theta formula is equal to 30h minus 11 by 2m. Now we want them to be in a straight line. So it will be either angle equal to 0 or 180. So let's put 0 first. If I put 0 first, it will be 30 into h has to be the smaller value, that is 4, minus 11 into 2m, 11 by 2m. So we get 11 by 2m equal to 120. And this gives us m is equal to 240 by 11. So it is equal to m equal to 240 by 11, that is 21.9 by 11. So the moment when the angle between them is 0 is 421.9 by 11. Does it fall between 4:30 and 5? No. So this is not our answer. Then that means we take theta equal to 180 degree for the opposite situation. Now same formula, theta equal to 30h minus 11 by 2m. So put theta equal to 180 degree and again do the calculation. So it is 30h minus 11 by 2m. And here is the catch. You cannot put theta equal to 180 degree, right? You have to put theta equal to minus 180 degree, because if you compare 4:30, if you compare 4 o'clock and the moment when they will be opposite to each other, at 4 o'clock, the minute hand is here and the hour hand is at 4. This is hour hand. Now minute hand is faster, hour hand is slower. Now it's very clearly evident that the minute hand has to cross hour hand and then go to this place to become opposite, to come in the opposite direction, right? That means minute hand has to cross. So if it has to cross, we will put the angle as minus 180. So minus 180 is equal to 30h minus 11 by 2m. So minus 180 is equal to 30 into 4 minus 11 by 2m. Remember, whenever the crossing has happened, the angle has to be taken as negative, right? So minus 180 is equal to 120. So 11 by 2m to this direction, this LHS, 13 to 4 is 120 plus 180 is 300. So m is equal to 600 by 11. If you divide, 11 5s are 55, 11 4s are 44, 6 by 11. So m value is 54, 6 by 11 minutes. So the moment would be 4, 54, 6 by 11. Now is this moment between 4:30 and 5? Yes. So the correct answer is this one, and here straight line would be the opposite situation. So the answer of this question would be C. Okay, so this is what we needed to understand in this question. All right. Now, there is another way to look at this question. Let's see. The other method of this question will depend on time, speed, distance method. All right. So I'll say other method for question number 30, question number 7. First, let's draw 4:30. So at 4:30, what is the situation? The minute hand is here, that is M, and our hand is between 4 and 5, exactly between 4 and 5 because it is 4:30. All right. So this is our hand. So first we need to find the right now the angle between them. Let's say it is theta. Now right now the angle between them can be calculated in two ways as we did earlier, right? Or we can calculate in a different manner. If you see, this R hand divides the total angle between 3 and 6 in exactly two equal parts because it is at 4:30, that is 4.5. 4.5 is between 3 and 6. So the angle theta would be straight away equal to half of the angle between 3 and 6. Now angle between 3 and 6 is 90 degree. So straight away it will be equal to 45 degree. So already the angle between them is 45 degree, and we want to make the line opposite to each other. We want to bring minute hand here. We want to bring minute hand here so that the angle between them becomes 180 degree. Now already the angle between them is 45 degree. We want the angle to be 180 degree. So the angle required to travel would be 180 degree minus 45 degree. That is 135 degree. All right. Now to travel, time taken to travel this 135 degree would be equal to time equal to 135, that is the distance, divided by relative speed, that is 6 minus half. We already have the speeds that we have calculated. Minute hand speed is 6 degree per minute and the hour hand speed is half degree per minute. So 6 minus half, right, it will be equal to, it will be half, 6 minus half, so it is 135 divided by 11 by 2. So time is equal to 270 by 11. If you divide, it will be 11 2s are 22, then 54s are, so 6 by 11 minutes. And this is 24 6 by 11 minutes after 4:30. Please understand that we have started from 4:30. So the moment would be 4:30 plus 24 by 6 by 11 minutes, and hence that would be 4:54 6 by 11 minutes. This is the time when they are in straight line, right? So the answer of this question would be 54 6 by 11 minutes past 4. That is C option. All right. Now in question number 8, it is asking how many times do the hands of a clock coincide in a day, right? That means they're together in a day. We have already done that calculation in question number 6. So I'll simply write from question 6. You can see that coincide is same as together, right? Now together, and they were 11 times in a cycle of 12 hours. 11 times in a cycle of 12 hours. That means in a day there are two cycles of 12 hours, hence the number of times they are together would be 11 into 2, that is 22 times. So the answer to this question would be 22. All right. Now let's look at question number 9. How many times are the hands of a clock at right angle in a day? Now this is very interesting, right? Let's start again counting the same way. From 12 to 1, how many times are they at right angle in a day? In between 12 and 1. Okay, let's see. I'll give you a brief idea. From 12 to 1, consider a moment of around 12:15, 12:16. So that is once. And then similarly around 12:50, another. So between 12 and 1, 2 times the minute hand and hour hand are perpendicular to each other. All right. Now between 1 and 2, again you can see that 2 times. Between 2 and 3, now mind this, between 2 and 3 they will be perpendicular to each other only once, that is around 225. All right. Between 3 and 4, again they will be perpendicular to each other at around, you can see it will be around 3:35. Okay, only once. But there is one more moment that is not been counted here, because we have been counting between. At 3, one extra time, right? So at 3, one more time. So one extra time, you can say, right? And then between 4 and 5, again 2 times. Between 5 and 6, again 2 times. So in general, you can see that within every hour they are perpendicular for 2 times, right? Except for 2 to 3 and 3 and 4, right? Similarly, 6 to 7, 2 times. 7 to 8, again 2 times. Now 8 to 9, only one time. I'll give you the moment. It is around 8 25 or 8:30. Between 8:25 and 8:30, that is once. Similarly, between 9 and 10, again only once, and that moment would be around 9:35, only once. But again, between these two, at 9 o'clock, we have been counting between 8 and 9 and 9 and 10. We have not counted at 9. Now at 9, one extra time. Okay. Similarly, between 10 and 11, exactly 2 times, and between 11 and 12, exactly 2 times. Right? If you count all of them, you can see that the total number of times that they are perpendicular to each other or at right angle are 2 plus 2, 4, 5, 6, plus 2, 8, plus 2, 10, plus 2, 12, plus 2, 14, 15, 16, and plus 2, 18, plus 2, 20. No, once again, 2 plus 2, 4, 5, 6, 8, 10, 12, 14, 15, 16, 18, 19, 20. How is it coming? It must have 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, 11 to 12. Right. So 20 and 1 this, 21 and 1 this, 22. So in a cycle of 12 hours, 22 times, 22 times in 12 hours, right? So I'll say perpendicular or right angle, perpendicular for 22 times in 12 hours. So the question is saying in a day. Now in a day there are 24 hours. So the total number of times in a day they would be at right angle, that would be equal to 22 into 2, which is 44. All right. This is how we have to do it. Then comes question number 10. We have already done that calculation. It says how many times in a day are the hands of a clock in straight line but in opposite direction. Now that counting we have also done in question number 6, where we did for both cases of together or straight line. So I'll simply write question number 10 we can get from question number 6. From question 6 you can see that opposite direction in a day, opposite direction in a 12 hours time, it is 11 times. Opposite is 11 times in 12 hours, right? 12 hours. So in a day, automatically in a day there are 24 hours, so it will be 11 into 2, that is 22 times, 22 times in a day. Okay, so in a full day they will be opposite to each other 22 times. So the answer of this question would be straight away 22. That counting we have already done in question number 6. All right.